developer, built with VB8, production-ready applications. Why does it matter? You will find other vector databases which are maybe easy to use or in the standard documentation of LangChain, but in the end, if you build a prototype, often it's a long-term commitment because you're building your prototype and then in the end, you want to serve this application first to 1 user, then to 10 user, maybe to 100, maybe to 1,000. And then horizontal scaling becomes relevant. It's so sad that I get rid of all of my socks. Do we still have pairs? T-shirts? Sad. What does horizontal scaling mean? Any ideas here in the room? So horizontal scaling means that we are doing the heavy workload for you if you deploy your application into production and then scale these horizontals. So you can build an application which is serving billions of vector embeddings, which is, and we take away the heavy load for you. One of the also production-ready features, which you'll not find in many of the other vector databases, is multi-tenancy, because that means that you have data isolation per tenant and you can run everything on one single infrastructure. As it's open source, we also have this GitHub repository with a VB8 recipe where you can easily look and play around with our multi-tenancy feature. Then product quantization is also one of the production-ready features for the enterprise market because it's a compression algorithm and it comes at the trade-off of you losing a bit of precision or accuracy in the trade-off, saving a lot of the memory footprint, and you can shrink this to up to 90%. And this is one of the features of differentiation, which is bringing us a lot of these mid-sized to large-sized companies using VB8. So, but now, as I would expect many people building machine learning pipelines in this room, let's come to the technical deep dive. I'm not taking everything because also Victoria is later on talking about hybrid search. I give you some insight how to build a production-ready retrieval augmentation generation pipeline with VB8. So a retrieval augmentation generation pipeline is doing one thing. You have internal information. It could be information for a product from your company, a large language model like GPT-4 or GPT-3.5 has never seen. So what you want, the user is asking specific questions and you want that the model is generating a specific output related to the asked question from the user. But to answer this user, you need this internal information because the model would not generalize the right information without having it. So what is the retrieval augmentation generation pipeline doing? We have all these internal documentation. The user is asking a question, something specific to the product, so a thing the large language model never has seen. Then we do a retrieval. The retrieval is search, in this case hybrid search, we already heard it. It's text search combined with vector search, and vector search brings you the semantic relations. We will talk later on why this is important in the hybrid search talk. So we're searching for all these could be relevant for the user question information, using all these chunks and putting these chunks into the context window of the large language model, which is then generating the specific user answer out of this information in combination with the stuff or the things the large language model has learned. Some of the techniques we are using in one of our tools, which we call Verber, and Edward is giving a deep dive into Verber. It's open source. You can just fork it on GitHub and do whatever you want with it. Completely open source, no cloud product included. You can run this on your own infrastructure and build a retrieval augmentation pipeline with a nice front end. So one of the techniques we are using to improve the retrieval of the RAG pipeline is chunking overlap. That means we are creating the vector embeddings and we're using some kind of entropy. This is an overlap between the chunks because there's a high probability that the chunk before and after the chunk we're ingesting includes also information which could help later on improve the search for this specific chunk because language is linear, so there's a high probability that this is related, the chunk before and the chunk after, with the information which we are having in the chunk we're ingesting. This is at the place creating the vector embeddings with an embedding creation model, like sentence transformer, Giga embeddings. whatever, or Cohere, or whatever embedding model you want to use, because it's open source. You can also plug in whatever open source model you want to use. You can also use the other model from OpenAI. So the next technique we're using is now happening at the retrieve. So first generation, now the retrieve, and this is used for the stuff we're putting into the context window of the large language model, and we call these context windows. So same mechanisms, high probability that things happening before or after are related to the chunks which we are using to generate output with the large language model. So we are doing a hybrid search, looking for these specific chunks, then we're putting them into the context window of the large language model to generate user-specific answers. We also have later on a practical demo showcase, so Edward is showcasing how this is working and how this is looking. I'm just giving you the technical test. This talk is later on also accessible online, and we are sending you the link to the talk so you can easily dig into the slides later. Semantic cache. This is coming from EOY out of the box, and that means that we are storing. The user is having not a similar question, but a related question on the semantic level. So what is a vector database? How do a vector database work? This is related on a semantic level, not on a keyword level. And if to some degree there's a threshold, and you have the full control about this threshold, so you can fine-tune it to your needs, but in the end we are storing this information, and if you're asking a semantic related same question under this threshold, we are not fetching the large language model again. This is coming then out of the cache. So this is there in a millisecond, and you do not need to use your API credits to generate the same answer again, because this is stored in the semantic level. Query splitting. Also for a large language model, it can be challenging if you have a nested sentence or a lot of sentence related to a specific thing. So sometimes it makes sense to split this sentence. So you have then stored two sentences which are created out of these long nested sentences, and store this information in the vector database to easily retrieve answers for the user, and use these two sentences in the context window of the large language model. Another technique we are using, which is improving the performance or the speed, is we're storing a summarize of a document. And one of the techniques you can use in this scenario is creating the summary context aware. So specific on a topic, you're handing this over to a large language model, and then give me a summary with this or related to this specific topic, and then we store this summary, which if you have a topic extraction, or if you're aware which topics should be included in the documents you're ingesting, this is later on improving the search and improving the results. But it's depending on the data set. This is not a general thing. This is always depending on the data set you're ingesting or the data you search. But for a lot of use cases, this is improving the performance and rank of the documents to output. Also, same mechanism, because language is linear. So if the user is having a conversation with your chatbot, there's a high probability that maybe something before is also related or helping generating better specific output for the user. So adding the dialogue to the context window to generate the output could also help improving the results and providing the user more specific results he's looking for. Here, this is a project I'm very proud of. So Connor has built this, and it's somebody aware what a gorilla model is doing, or the large language model, gorilla. So it's trained on APIs, and it's helping us. We have fine-tuned this on the API of Viviate, and this opens the window for very advanced querying techniques, because we're using natural language and then generating a query, which is also including attributes and filters. And I have a nice demo showcase, but I need to speed up. Yeah, maybe I'm skipping the demo. So I will also include, it's called health search, and with health search, you put in natural language, and then the query is generated, and this is later on also included in the follow-up. So re-ranking. Now I'm rushing. Re-ranking comes at a cost if we do this with a transformer model. So because regular text search and text ranking is super easy to do, not a lot of processing power, but if you want to do the more advanced re-ranking, which is most of the time including the transformer model, it's costing you processing time. But it's also improving the ranking results. One of the techniques is later on explained by Victoria, and multi-stage search. So this is using a transformer architecture to improve the re-rank or the ranking results. And one of the techniques you can use is the LLM is taking the query and the documents which are related to the query and then giving me a ranked results back. So it's doing this 1 to 100 result, but this is a large language model, so this is costing you some processing power. Then the multi-document strategy is just that you're feeding in all the documents you're having and saying to the large language model, give me the ranked version. So this was Verber, where Eddie is giving a deep dive. And thank you. Then
don't look at my desk.
No, let's
Nein.
Warum bist du Müller? Wir sind Müller. Was ist denn einfach Müller?
Hi folks, I am Victoria. I'm Victoria, and today I'm going to be talking about hybrid search, which I think has become a bit of a buzzword around certain contexts, but I'm going to be taking a slightly different approach to it. A lot of talks go into the hybrid search of kind of a how-to, like how to use hybrid search for certain use cases, what the effects are. I'm not going to talk about that today, not because I don't think it's interesting or important, but because it is really, really easy to do in V8. Okay, so in V8, you just have to change that little thing called hybrid there and change it to semantic or VM25 for keyword or hybrid if you want hybrid. And if my whole talk was about just implementing that solution and testing it out, well, you can do it yourself, test it yourself. I am instead going to spend a lot of time here talking about the how of hybrid search, kind of what's going on behind that one-line change in V8, why V8, a vector database, really decided to make a keyword search option a priority, and how that has really set us apart in the vector database world. I'll end with a few whens, when you might want to use hybrid search, when you might not want to use hybrid search, and a specific use case in the end. So hybrid search is most often the combination of vector search and keyword search, which I think someone pointed out before. And implementing hybrid search really has everything that's really hard with vector search, plus everything that's really hard with keyword search. And on top of that, you have to kind of combine those two results together from the two different algorithms using a fusion algorithm. So it's not an easy concept, but we're going to go through it all, starting at the top, vector search, then keyword search, then fusion algorithms, and I'll spell it out all for you. So, because we're a vector database, we obviously provide vector search. If you're not familiar, for vector search to happen, you need all your documents, which is everything in your database, and also the query, which is the text thing the user gives you, to turn into vectors. And the vectors basically encode the meaning of the text or image or whatever in sort of a numbers format. And in order to actually talk about searching through these vectors, we actually first have to dive into this thing called ANN algorithms. So ANN stands for approximate nearest neighbor, and it's used for vector search because it's a lot faster than individually going through each vector in the vector space and searching for the ones closest to the query. The brute force algorithm is called KNN, or K nearest neighbors, and it doesn't scale like at all. So when I say nearest neighbor, I'm talking about the vectors like closest to the query in the vector space. The closest vectors are the most relevant to the query, kind of in this vector graph thing that comes up. And so when the user inputs a query, the algorithm searches for the nearest vectors to that query, and then fetches those documents back and provides them to the user. ANN is approximate because, well, it's not exact. The algorithm does some stuff to make it a bit faster, and so you can't guarantee that you're going to get the exact nearest neighbors from the algorithm, but it's really, really good, actually, and it's fast, which is the most important part. There are a ton of options out there for ANN algorithms. I don't really have time to go into all of them. You might know Spotify's EOY or some other ones, but let's get into WeVH choice, which is HNSW. And HNSW stands for Hierarchical Navigable Small World, which I can never pronounce, but WeVH uses a custom implementation of this, and basically it organizes vectors into a hierarchical multi-layered graph structure, which helps quickly navigate through the database during search operations. So this is an example of when the graph is being constructed, a little simplified animation I made. So basically it starts with all the vectors on the bottom layer, or layer 0, and then each layer above takes a smaller sample of the vectors below while maintaining this like connected graph structure between all the vectors. So the longest distances end up being at the top of the graph, and the shortest distances end up being at the bottom of the graph. And so this is why it's called kind of a small world, because having these limited connections really helps maintain this efficient searching structure. Okay, so then we can go into when a query comes in, and basically the algorithm starts at the top layer, and it finds the closest vectors in that layer from the entry point, and then it moves down to the next layer, and it takes the vectors that it found and expands them in the next layer, bringing all the relevant vectors into memory so it can work with them, and leaving all the rest behind. Then it finds the nearest neighbors again, takes those, moves down to the next layer, and repeats until it gets to the bottom, and it basically returns all the nearest neighbors on the bottom layer. Yeah, so HNSW has a lot of benefits, and I feel like it's a pretty popular choice out there in the vector database world. It's super efficient memory-wise because it's only really calling the relevant vectors from each layer into memory, and it's really fast because of the hierarchical structure. It doesn't have to move flat, right? It can move kind of through 3D space. There's a bit of a myth that HNSW only works for static datasets, and it doesn't work when you're like doing frequent updates or deletes because you need like periodic rebuilds, which means building the whole entire index graph thing from the ground up whenever you delete something, because otherwise you'll have like missing connections and stuff like that. Lucky for WeVH, we have built a custom implementation of HNSW within our vector database. So we're not limited really by the limitations of other external libraries. Because of this reason, Etienne was able to come up with a really good solution for handling updates and deletes within our HNSW algorithm, and it works really well, which is really cool. Okay. Whew. Breathe, Victoria. Okay. So at the same time that vector search is doing its thing, keyword search is also going on within all the computery hardware stuff. So in order to efficiently perform keyword search, you need a way to efficiently search for keywords in your documents, right? So enter the inverted index, which this is an example of how it works, which is kind of our non-vector driven secret that allows us to offer things like hybrid search or keyword search, and also really quick filtering on the property level. So in WeVH, each property gets its own inverted index looking like this. And in the inverted index, instead of a bunch of documents storing a bunch of words, you have a specific word with a list of document pointers in which that word occurs in. And you'll kind of see why this is helpful in a second. But yeah, this is kind of the process it looks like. I've been learning how to make animations, so this is the fruit of my labor. Okay, so the actual search algorithm we use in WeVH is called BM25. So BM25 takes into account three things. The first is term frequency, which in one document, how often does that term occur? The second is document length, so it penalizes documents that are longer than the average length. And the third is inverse document frequency, and this is where the inverted index really comes into account. And this is basically how many documents the word actually occurs in, and this kind of measures the importance of the word. Yeah, so when a query is ingested into Weebit, it tokenizes it, so it takes out all the individual words, and then using math, yay, we calculate the inverse document frequency for each term in the query. So words like I are probably in a lot of documents, but pizza, maybe not so much. So then we score all these words using the IDF math thing, and then we apply the WAN threshold, which basically orders them in order of how relevant they are to the query, and then cuts off any that don't really add anything. So now we have our keywords, and then we calculate the full BM25 score using the three things mentioned there for each word in the query, or for each document relative to the query, which is the sum score of all keywords. Yeah, and then we put all the documents in order. Ta-da! Okay, so now we have a list of the top N documents from the keyword search and also the vector search. And now we need to kind of fuse these results together because they're not super compatible just the way they are. So Wi-Fi actually supports two different fusion algorithms as of 1.20, which is rank fusion, the first one here, and also relative score fusion, coming up in a second. So rank fusion is the original algorithm that Wi-Fi supported for hybrid search. And it doesn't really take into account the original numerical score that comes out of BM25 with the vector search. It just basically, for the results, it takes 1 over the rank of the keyword search plus 1 over the rank of the vector search, and then the end result is the overall rank. So you can see here for document A, its rank in BM25 is the first one, so it has 1 over 1, and the rank in the vector search is third, so it has 1 over 3, and the end result is 1 over 3. Ta-da! Okay. Relative score fusion works a little bit different. So this one actually takes into account the original score provided by BM25 and vector. So let's imagine, for example, you have 3 documents. These are the scores outputted. And you can see that they're pretty incompatible. Like, if you were to just add those right now, it wouldn't really mean anything. So what relative score fusion does is it takes all the documents and it basically normalizes them, so that the one in the top position becomes a 1, and the one in the bottom position becomes a 0, and then all the kind of scores between them, I don't know, distances between them. Right, so you can see that's kind of what it looks like when it's been normalized, sure. And so you see then the end score is just the result, like of both added up and it's normalized, so it makes sense, and voila, yay. Okay, so fusion algorithm re-ranks the documents. Cuts up all the excess, and woo, now you have the most relevant documents from keyword and vector search. But why? For you vector people who work on vector databases, you're probably like, why even bother adding keyword? And for all you keyword people, probably like, vector sounds complicated, why? And to answer that, we first have to talk about some of the benefits and drawbacks of both systems. So vector models are really great at capturing the meaning behind queries and documents, like returning related results without needing to have the exact right words in the query. They also deal with queries in natural language really well, and it works really well with typos. However, they can really struggle when working with out-of-context domains, in other words, domains that they were not trained on. Short queries are not usually super great, and specific term matches for like product names or industry jargon can be tricky. On the other hand, keyword search is robust, like across domains, because it's really just searching for exact matches between the keywords and in the query and then in the document, which is nice. It also handles short queries really well, and rare words and industry jargon, totally cool. It can miss out on relevant documents though that may not use the perfect words in the query, or have typos, or just like general question about general things in general language format. Doesn't do too well. So, hybrid search allows benefits of both systems to shine through without any of the drawbacks, which is really nice. The system can handle natural language, synonyms, typos, all the good things about vectors, but it can also deal with short queries, out of context terms, and what's the last thing? Yeah, those specific words, industry jargon. So basically when one system fails, the other is there to catch it. Always gonna get you relevant results. So, with all this in mind, when would you actually use hybrid search? You can see it kind of as an accuracy performance trade-off. So basically, if you have a super specific model trained exactly on your data, chances are vector search is probably going to be good enough. On the other hand, if you have usage patterns that rely really on like keyword matching, like copy-pasted descriptions, rare words that match exactly, there's a chance that keyword-based search is probably good enough. But if either of those is not good enough, hybrid search can likely get you the best of both worlds. The cost is that you're doing 2 searches for every 1 user-initiated search, so you're basically cutting your possible throughput in half, but it can definitely give you better accuracy. So, kind of depends on the use case. Okay, I want to end by talking about probably my favorite use case for hybrid search, mostly because I owe this website for helping me jumpstart my journey into programming, back when I was looking up how to combine 2 strings and have fun. Stack Overflow is an example of a use case where the end result, or the end goal, is search, right? So keyword search, which they previously still, I think, used, allows them to filter relevant context by the query only if the documents have the exact word in them. So this can definitely work well in a lot of documents, especially Stack Overflow, where you have very specific technical words, jargon, and you very often need that very specific phrase match in the answer. However, you can also miss some related posts that may not have the perfect words because it really doesn't capture the context or the meaning of the query or the documents. So, however, just providing semantic search may also not be the best decision for a site like Stack Overflow, where technical jargon, specific terms, phrases are super common. So without keywords, the results could end up missing very good things that you would like to have in your answers. So hybrid search can help provide them with the best of both worlds, which is super nice. And it still allows you to maintain the important specificities of the search results without losing on like relevant semantic information. Okay, and so with that, I will end. To get good results, you should need a bunch of words, and semantic search can help with that, and hybrid search can help with that, and that is what I want to do.
Hello, test. Okay, let's see if I get it working like this.
It's mirror.
Let me try to mirror my computer.
I'm here now doing the entertainment because it's better that he's mirroring his display because he wants to show the live demo, otherwise he needs to always do the break. I would use these to take a selfie with you because I missed these for my talk. If anybody is not fine with that, just... You can also a bit shouting because it would give Edward a lot of energy. Nice! I learned so much about hybrid search. Crazy.
Okay.
Are you ready?
Are we ready?
Okay, I do the mirroring, you do the entertainment.
Okay. Hello everyone. I'm now in charge of the entertainment. So I think I can begin because I don't have pretty slides like they both do, because I was so busy making them for them. But yeah, we heard a lot of technical stuff, tips and tricks, and how hybrid search works. And now in the remaining last minutes, I wanted to show you something more chill, just a demo, walkthrough, something nice to look at. Is it working? Yes. So Philip previously talked about RAG, and if probably somebody doesn't know what that even means, RAG stands for Retrieval Augmented Generation. And if that doesn't tell you what it is, let me explain it to you in simple words. In RAG, you have a query, a search query. You search through things with your search algorithm, you get stuff back, which is related to that query. And then you use a language model that generates an answer based on the stuff you just got. And that's all about what RAG is. And because it sounds so easy, we tried to build a little live demo called Verba, which is open source. yeah, that's the thing that I wanted to show you, to make like these concepts that were talked about earlier on the tips and tricks to like more tangible. And what's pretty cool about this instance right here, it's a live demo, so you can easily go to it, verba.vva.io, it's free, it's happy. The cool thing here is we ingested this rack setup with all our VVA documentation, blog posts, and also video transcripts, because we have YouTube videos. And you should subscribe us. And this basically is now a chatbot on steroids, perfectly aligned on everything that is about VVA. So you can ask basic questions about VVA, or you can ask like a program helper. So let them just present it to you and hopefully it works. So let's start with something easy. What is VVA? Right. Please work. Please work. So okay.
Local deployment.
Yeah, then we refresh and pretend nothing happened.
That's not us. That's ChatGPT.
It's all over. All right, it worked. So what we get now is a cached response, because somebody asked this question already, which was probably me. We get the answer to our question, and the things that just pop out are individual chunks of our documents. So we can click through them, and you see that the right window is changing. And this is like showing us the extract or this chunk of this specific document. So what we can also do is, let's go your developers VBA, blah blah, click on it, and then you go to the original document. You also get some like the yellow thing is indicating it's a documentation, or it's a blog, or it's a video. And yeah, so this was a pretty basic question. Let's ask something like how to use hybrid search. And then we'll retrieve another chunks. So something I also might mention is that we're using hybrid search to retrieve those chunks. And these numbers are scores with the relative score function, which you learned about just now. So you know exactly what those numbers are talking. And then we get a cool, nice response. It's still generating. And yeah, we get like code examples and cool stuff. And I'm honest, I've been using Verba a lot about Verba VBA questions. So whenever we had some support tickets and I didn't know what the user was talking about, I just asked Verba and it actually helped. So to make it, like to show you more cool stuff, let's deploy this locally. And yeah, Verba is open source, it's free, it's on GitHub, it has 1,300 stars, which means it has a lot of issues. So if you're an open source contributor, please help me. This is a cry of help. It's growing. It's growing. So yeah, we have a GitHub. You can go here, have fun. It's easy to install, like pip install called Verba. You add some environment keys, and then you're ready to go to ingest your own data. We will skip this deployment stuff and just have it here locally. Let's go to search. So this is currently running on my localhost 8000. And one cool thing about Verba is that it's not restricted to one kind of library or technique. If I try to add a document, we can see like different steps or different configuration that we can choose. So at the beginning, we can choose what kind of data we want to ingest. Is it a symbol reader, or like text, markdown, or JSON? Is it a PDF reader? We're using the PyPDF2 library. We want to download something from GitHub using a GitHub token, or using unstructured I/O if we have some special needs when we ingest PDFs. Or do we want to change the chunking technique? Do we want to chunk by tokens, words, sentences? Do we want to embed our vectors through sentence transformers from Hugging Face, which can run locally, or Ada Embedder from OpenAI, Cohere, whatever? And cool thing here is that you can easily add new components to it. So if you have your favorite library like Haystack, you said, or Gina, you can easily add it. So it's not restricted to any library. And the same goes also for generators. So like the components that generate the responses, you can do GPT-3, Cohere, or Llama 2, which also can work locally. So you can essentially use Verba completely locally so that your data does not go anywhere. But you must have a good computer to run a LLM on your own. So let's stop talking and add some cool documents. And before I ingest documents, Philip is always telling us when we do demos or showcase anything, we should really have business use cases or real-life examples. And because of this, I'm going to import the Minecraft guide. Yeah. So who in the audience knows about Minecraft? Who still plays Minecraft to this very day? See, it's still business. It's a good bit of business use case, so we're going to upload it. We press import, hope for the best. So this is the log right now. I'm not sure if you can see anything, but something on that black screen is happening, which is a good sign. So if we're lucky, it's importing. And we got a green happy bar. And now we can go ahead and ask anything we want to know about Minecraft. So let's start with what is Minecraft. So we see the chunks are then popping up. You can check the extract and Minecraft, open-ended video game, sounds similar, right? Which is pretty cool. And also, kind of this visualization really shows why you could use Rag4. So first of all, because you have these sources you can check, you can reduce hallucination of these large language models with your own data. And another thing is that you can really utilize powerful models like GPT-4 or Llama or Mistral, any, to your specific data set. So, for example, you want to read the newest paper that was just released and want to use RAG for it. GPT-4 would probably not know about this paper because it was not included in the training data set. But if you use a setup like this, you can use any data set, whether it's Minecraft or it's a bachelor thesis, whatever. That's a really good use case. So basically RAG is the better chatbot, or a good way to have a chatbot. So, blah, Minecraft, that's good. Yeah, that's enough. So if you want to know more about Verba and a more techie person, there's the video of this guy who looks just like me, explaining the concepts, going like how to install it, how to set up stuff, how to have fun with Verba. If you're the person to read, we have some very cool Medium articles that random people wrote, which is very flattering. I really like this one because it really goes into the depths of how Verba works and the crazy stuff I had to deal with. And we also have some other Verba stuff, which is nice. And yeah, I hope you liked it. And with that, I'm ending the VV8 presentation. Thank you very much. Of course, do you have any questions about any presentation?
How about like hybrid search? So how does this actually work? Is it consecutive keyword search and then vector search, or any more sophisticated?
You mean it's Verba in specific, or the retrieval augmentation
No,
generation?
I mean the previous presentation about hybrid search. So how much is it hybrid? Is it just first keyword and then vector based, or the other way around? Or
You mean
So it happens at the same time, actually.
oh, so it's just two parallel searches,
Yeah.
and then you pick the best results, or
Yeah, so it happens.
you sum up these results.
So it happens in parallel. Basically, the vector search goes and the keyword search goes same time.
Oh.
And then once you get both results, then it can go through the fusion algorithm,
Oh.
and then that basically happens. So keyword search is a little bit slower than vector search, so that's kind of the main thing holding it up. But they do happen at the exact same time. That answers.
Some more questions?
Can you explain how the images can work? Like, do you need a separate model to train on that?
Images or?
Images, yeah. To generate the embedding or how to?
Exactly, there are different models. Also? Why not?
Yeah, so with VBA, basically anything that can be turned into vectors, you can use you can use vector search with. So you can turn images into vectors, so you can use vector search, you can use image to text search, you can use text to image search, you can use image to image search, and we have lots of good stuff coming on multimodal RAG soon, so keep an eye out for that. But if you're interested, I also have a few resources that I can send you. Yeah, it's really cool.
And we use for multimodal embeddings ImageBird from Facebook. So there's a paper implementation, and you can fetch or use the model right out of V8 to view multimodal whatever it is.
ImageBird?
There.
It's somewhere.
Okay, more questions?
Say I had a big Notion garbage pile, like how much effort to put verbal over our Notion and index it and get it useful?
There are several ways to do this. So first, there's an HTML and Markdown export out of Notion, but there's also Numar AI, which is a tool for building ETL pipelines. They have a Notion connector, so you can easily just add your credentials, your connection, your API, to Numar AI, then ingesting this data and feeding them and creating these embeddings with V8 and store them in V8, and then using all these advanced search techniques to search through this pile and do whatever you want to do with it. But also possible to just export the Markdown files because Verber understands Markdown out of the box. You just need to ingest then the folder storing these Markdown files in Markdown.
Sorry, what's the name for the ETL tool?
Let me.
N-E-U-M.
N-E-U-I.
Here, so we're partnering with them a lot, and they're building these ETL tools. So ETL means enload, transform, load. So you have data, you do a transformation, and then you put it somewhere. This is a classic ETL pipeline, and I mean, Edward and me were building ETL pipelines 5 years ago. Now it's becoming a thing again in machine learning, so why not? Yeah, it's a pretty nice tool because you have all these connectors out of the box, and it's also they're supporting open source. All questions?
I have a question.
Yes.
So let's say I have a use case where I'm querying like certain attributes from a database. So for example, if I have a database or a CSV file or whatever with some certain attributes which are numerical, and I want to query something like which has the best or the highest or the
You want to ask a table a question. A large language model should give you an answer to a specific column or row out of a table. There are several approaches to this, so there are also dedicated models which are useful for doing this. We then can also say, give me the information. You're asking this spreadsheet with natural language, and then you can also add stuff like, what is the sum of x, y, z, and then multiply this by 10, and the model is generating for you the output. But it's depending on the use case. If it's not a too advanced spreadsheet with too much information, it's enough to do this with a large language model like OpenAI, just feeding in the right embeddings, and then using this text information. It could be hard, because if you now have these columns and these rows, what you can do is you're adding this as an attribute to the thing you're storing, so the column name. This is the information for house prices, and then you have the house prices. And then you also need to add the information of the row, and then you can specifically hint to these kind of things. So it's possible to build these, but as I said, there are also open source models which are specialized answering information which are normally in a structured way. So that would be the use case.
But would the hybrid search would be any kind of help here in this use case?
It's depending on the table you're feeding in, but a lot of these use cases are working with this information Do we want to use the iHeart dataset as example, or?
I have a question about your question. Are you talking about like filters? Like you have like natural language, give me the products with higher number than this?
For example,
Yeah, so this is kind of what's called kind of self-querying, where you have natural language that is then converted into like a query. And we have a little demo here, which is about like supplement products. And we have a line like products for sleep from the Now Food brand. So we kind of enter a filter inside our natural language. And then we use an LLM to generate a query where a filter is automatically applied. And you can do this for any attribute. However, this has nothing to do with hybrid search. Because like you can use hybrid search together with filters, but hybrid search will not automatically create filters for you. Yeah.
So, but this is also where these Gorilla model come in advance to create this query with more advanced filter settings. So it's called retrieval querying, and this helps you getting the structured information out of these tables. But you're ingesting the vectors, but always with these metadata. So that's the trick. That's what I called, you add these as attributes, that's metadata.
On that example, could you query the description and then use
Sorry?
Could you query the description?
You want a description of the product, or?
Yeah, so whilst you're
Let's try it.
You're filtering on attributes, but could you query something that's within the description?
Sleep. Let's go.
Let's see. Maybe we break.
Okay. As explanation, this is original a pharmaco pipeline we built back in the days with Spacey and an old NLP stack, and this is a rebuild with VV8 and advanced large language models.
Oops, sorry.
And we switched the dataset to a supplement dataset because it's easier to understand for people than a pharmaco dataset with patient or doctor notes.
Let's just test this because it's returning a similar cached one. I just want to see if the query is correct.
So, and normally users are fetching or asking these demo showcase, what is helping my sleep?
Nice.
And if this is technique and something can go wrong, it's pretty sure it's OpenAI again. So we're doing everything right.
Theoretically, it should work.
It's just a large language model. But the demo showcase is showcasing these semantic relationships, because if you're fetching, the user is asking what is helping my depression, a lot of these treatments or positive drugs effects the supplement can have, also the medication. People having depression, is just my example, also are prone to anxiety, because this is one of the most dependent symptoms of a depression. That not always, it's depending of the kind, because this is also language is unspecific. Somebody is talking about the depression, but it's an umbrella term. It can be a bunch of diseases which are related to a symptom or to a clustering of specific symptoms, and these semantic relations. So I'm asking what is helping my anxiety, what is helping my depression, is leading to some semantic related outputs. Do we want to show more, or
Yes.
giving up?
Thank you, Phil.
OpenAI is down, sorry.
Yes. It's true.
Mathis. I'm with DeepSet. I'm the head of product. As Philip pointed out, normally we would have Tuana standing here, our lead developer advocate, but she can't be here today, so I'm presenting. So bear with me also if the presentation is a little bumpy. I just got this yesterday evening. But in any case, I also want to ask you, but I give you a heads up right away. I don't have any socks. I have stickers though. So who of you knows Haystack already? Okay, folks in the back. Have you used it as well? All right, cool. So let me tell you a little bit about Haystack, what it is. We just came off of our 2.0 beta release last Monday, this Monday actually. So we just released a new major version, which is a big milestone for us. And now let me just get into it. So Haystack is an open source Python framework, an LLM framework. It allows you to build flexible pipelines like the RAG pipelines that EOY just shown, and also semantic search, question answering, table QA, for example, and many more things that you can imagine. And basically, when we started building Haystack 2.0, we thought, okay, people seem to like this framework, and they use it, they like it, they give good feedback, but we really want to improve it. And then we thought about the state of the entire LLM ecosystem and other frameworks like LangChain, LlamaIndex, our framework, and we thought, what's really the differentiator here? We have all these bunch of components. You can query a large language model. You can have the embedding models. You can have all the vector DBs. The Aviate is in there, for example, so you can use that one. But that's the same for every framework. And what we heard from our community was, well, Haystack is pretty stable and we like it because it gives us that production readiness. And I'm a product manager, so I'm head of product at DeepSet. Production readiness doesn't give me much. It's like, okay, what does that mean? And then we went on a quest to figure out, okay, what does production readiness mean for our community? And we interviewed people, and pretty quickly we figured out, oh, people really seem to like our pipelines. And I give you an example. I interviewed ex-Netflix engineer, and he had built a Slack QA bot in 2019 with Haystack. And that was pre-ChatGPT, it was pre-RAG, it was an extractive QA pipeline. So it's a different transformer model predicting where's the answer in that text. And he said, well, I chose Haystack because the pipelines provided me with an abstraction that didn't get in my way, but it also kept my code organized. I could have other people come in, use the code, understand it, and we thought that was pretty great. And we heard again and again in every conversation we had, oh, your pipelines are great. They help us keep things organized. So we thought for 2.0, we're actually going to focus on these pipelines. And we want to make them much more powerful, support much more use cases. Like, you might have that simple RAG use case, but as we heard right just before that, maybe you start with vector search, but then you realize, oh, I want to add hybrid search, so I want to have the BM25, and then I want to add another transformers ranker, and maybe I also want to classify my query before it goes into the retrieval, because I want to use different retrievals depending on the type of query. And that's where branching comes into pipelines, where business logic comes in. We need to customize things. And one example is a big newspaper we're working with, and they have different types of queries. Like users come to their page, they build a RAG pipeline, and users come to their page and they're like, okay, give me the latest election results in Poland, for example. And that's a time-sensitive query. But then people also ask about, hey, what's a good city to live in? And that's a very different type of query. And for the first query, time is of the essence. So you don't want to pull up election results from 2014 or anything like that. You want to have the latest selection results. So that means that you need a time-based ranking component on top of all the other retrieval components. If you're asking for the best city to live in, though, it's a much broader topic. Like you want to have different perspectives. You want to have articles from the entire archive, probably, and there you don't want to have that time-based retrieval, time-based ranking on top of all the other things. So they decided we want to have a query classifier in front of it that tells us, is this a question that asks for recent events, or is it a question that's just general and we want to have general retrieval? And that's really what you can build with these flexible pipelines. I also brought you the RAG pipeline, and you can see right here pretty much a query goes in, it's embedded into vector space. The vector is used to retrieve data from a vector store.